Hello, math learners! Our lesson for today is about parabola as conic section. The learning objectives are: you are going to define terms related to parabola as conic section, find the coordinates of the focus, vertex, directrix, axis of symmetry, and latus rectum of the parabola. Determine the equation of the parabola in standard form and in general form. Sketch the parabola and solve real-life problems involving the concept of parabola. This is the Learning Pocket concept map. So we will be discussing the forms of the equations, the parts of the parabola, the graph, and the applications. A parabola is the curve formed by the intersection of a plane and a cone when the plane is at the same slant at the side of the cone. And this is the illustration. So you have the cone, you have a plane intersecting the cone, and this curve is the parabola. A parabola can also be defined as the set of all points in a plane which are at equal distance away from a given point, called the focus of the parabola, and a given line called the directrix of the parabola. So in this illustration, this point above the vertex is what we call the focus, and this line here passing through this point is what we call the directrix. If you're going to draw a segment from the focus to a point on the parabola and drawing a segment perpendicular to the directrix, then these two segments are equal to each other. From this point to this point, and drawing a segment perpendicular to the directrix, these two segments have the same measurements. This line can be considered as the axis of symmetry. The parabola is a curve formed from all the points with coordinates xy that are equidistant from the directrix and the focus. The line perpendicular to the directrix and passing through the focus, that is, the line that splits the parabola up the middle, is called the axis of symmetry. The point on this axis, which is exactly midway between the focus and the directrix, is the vertex. The vertex is the point where the parabola changes direction. Let us have the vertical and the horizontal parabola. This is the illustration of a vertical parabola, wherein you have the vertex, this is the focus, this is the directrix, and this is the axis of symmetry. The axis of symmetry is vertical. For the horizontal parabola, you have here the vertex, this is the focus that is always inside the parabola, and this is the directrix, and this line is the axis of symmetry, and the axis of symmetry is horizontal. Let us have the standard form of the equation of the parabola with vertex at the origin, or the coordinates are 0, 0. The standard equation of the parabola with horizontal axis of symmetry y is equal to 0 is y squared is equal to 4px. And the standard equation of the parabola with vertical axis of symmetry, or x is equal to 0, is x squared equals 4py. the focus for this equation, we have the coordinates P is equal to 0. We have to let the distance from the vertex to the focus be represented by P. And the coordinates of the focus for this equation, we have 0, P. For the opening of the parabola, if P is less than 0, the parabola opens to the left. If P is greater than 0, the parabola opens to the right. In this equation, if P is less than 0, the parabola opens downward. And if P is greater than 0, the parabola opens upward. For the latus rectum of the horizontal parabola, the equation, we have x is equal to positive or negative P. Direction of the latus rectum is a vertical. The length is 4P. For the equation of the latus rectum of the vertical parabola, we have y is equal to positive or negative P. Direction of the latus rectum is horizontal. The length is 4P. For the endpoints of the horizontal parabola, we have the coordinates P and positive or negative 2P. For the vertical parabola, the endpoints of the latus rectum, we have the coordinates positive or negative 2P and P. The equation of the axis of symmetry for the horizontal parabola, we have y is equal to 0 or the x-axis. For the equation of the axis of symmetry of the vertical parabola, we have x is equal to 0 or the y-axis. Direction, we have here horizontal, while here we have the vertical. For the equation of the directrix, here we have x is equal to negative P. And for vertical parabola, we have y is equal to negative P. Direction of the directrix here is vertical, while for the vertical parabola, the direction of the directrix is horizontal. Take note, the parabola always bends towards the focus and away from the directrix. The distance from the focus to the vertex is represented by P, and the distance from the focus to the directrix is 2P. The line through the focus perpendicular to the axis and intercepted by the parabola is called the latus rectum of the focal chord, and the length of the focal chord is called the focal width. Let us have illustrations. Again, we have to let P be the distance from the vertex to the focus. Let us have first the illustration of the vertical parabola with vertex 0, 0. So here in this illustration, the vertex is located at the origin. And this point above the vertex is what we call the focus. And this is equivalent to 3 units. From the vertex, counting 3 units down, we have this point. And we draw a line passing through this point, and we call this segmented line as directrix. This point is one of the endpoints of the latus rectum. And this is the other endpoint of the latus rectum. This segment is what we call the latus rectum. And we call this segment as the focal chord. And the measure of the latus rectum or the focal width is 4P. So from here, from the focus to one of the endpoints is only 2p. Next, for the horizontal parabola, we have the equation y squared is equal to 4px. So the axis of symmetry is the x-axis or the horizontal axis. This is the vertex located at the origin, and to the right of the origin, this point is what we call the focus. The distance from the vertex to this point is represented by p, which this point is called the focus. And from vertex to the focus is represented by negative p0. And passing through a segmented line or a broken line, this line will represent the directrix, wherein the equation is x is equal to negative p. This is the endpoint of the latus rectum, another endpoint of the latus rectum. The latus rectum is equivalent to 4p. From here to this is only 2p. Let us have an example. Find the coordinates of the focus, vertex, the equation of the directrix for the parabola, and the other characteristics of the parabola x squared is equal to 12y. And then you have to draw the parabola. So given x squared is equal to 12y. For the solutions, you have to copy the standard form. And the standard form is x squared is equal to 4py. And use the given. The given is x squared equals 12y. And then we have to solve for the value of 4p. This 12 is simply equivalent to 4p. So 4p is equal to 12. And simplify. So we have to divide each term of the equation by 4. And cancel 4. So p is equivalent to 3 units. For the graph, you watch this video. So you have the vertex, count 3 units up, that's the focus, 3 units down, and then you draw the endpoints of the latus rectum, then draw the parabola, then draw the latus rectum, and last is you draw the directrix. And see to it that you are going to label properly your graph. So this is the focus 0, 3. From the vertex, it's 3 units up. This is equivalent to 2p. So that's 3 times 2. 1, 2, 3, 4, 5, 6. And also with this 6. And the length of the latus rectum, that is equivalent to 12 units, which is 4p. And the distance from the vertex to the focus is equal to the distance from the vertex to the directrix, this line. So the directrix is passing through 0, negative 3. This is the axis of symmetry, which is the y-axis, or equivalent to x is equal to 0. And let us identify the corresponding values of the parts and other characteristics of the parabola. The value p is equal to 3. So focus is 0p, so that is equivalent to 0, 3. For the vertex, we have 0, 0. Directrix is equal to negative p, so y is equal to -3. That's the equation of the directrix. For the axis of symmetry, x is equal to 0, or simply y-axis. The equation of the latus rectum is equivalent to y equals p. So, it is y is equal to 3. The endpoints of the latus rectum can be computed by these coordinates -2p and p and 2p and p. So -2 times 3 is -6. Then you have 3. 2 times 3 is 6. And you have 3. So the coordinates of the endpoints of the latus rectum are -6, 3, and 6, 3. The length of the latus rectum is equivalent to 4p, which is equivalent to 12 units. So when you count from here until here, that is equivalent to 12 units. And the parabola opens upward because p is greater than 0. So this is an example of a vertical parabola. Next, example 2. Find the coordinates of the focus, equation of the directrix for the parabola, and the other characteristics of the parabola. Given y squared is equal to 10x. And then you have to draw the parabola. Given y squared is equal to 10x, for the solutions, so again, you have to copy the standard form, which will start with y squared is equal to 4px. And copy the given, y squared is equal to 10x. And then, we have to solve for p. 4p is equivalent to 10. So, the number before x is the value of 4p. Then divide by 4 and also here by 4. So, what we have is 5 over 2 or 2.5. So, you watch this video for the graph. This is the axis of symmetry. You have the vertex. Then from the vertex, 2.5, that's the focus. So you have another point, and you can draw later on the directrix. The endpoints of the latus rectum, you draw the parabola. And this is now the latus rectum. And then you have the directrix passing through this point. See to it that you will label the graph properly. So from the vertex to here, that's 2.5. That's the value p. And this is the focus with the coordinates 2.50. Then this is from here to here, that is equivalent to 5 units because that's 2.5 times 2. From this point, from the focus to this point, that is also equivalent to 5. A total of 10 units. That's the length of the latus rectum. The distance from here to here, that's 2.5. That is also equal to the distance from the vertex to the directrix. So this is the directrix. The equation of the directrix is x is equal to 2.5. And the axis of symmetry is the x-axis, or y is equal to 0. So let us identify. Again, for the focus, we have P0, so 2.50. Vertex, V00. Directrix, x is equal to -2.5. Axis of symmetry, y is equal to 0. Equation of the latus rectum is x is equal to 2.5. The endpoints are 2.55 and 2.5 -5. The length of the latus rectum is 10 units. And the parabola opens to the right since p is greater than 0. Next example. Write the equation of the parabola with vertex at the origin and the focus has coordinates 5, 0. So given focus with coordinates 5, 0 and vertex 0, 0. For the solutions, the focus 5, 0 is in P0 form. The form y squared is equal to 4px with p is equal to 5. So this is the given. All you have to do is to substitute 5 to p, and we have y squared is equal to 20x. This is the equation of the parabola, which is y squared is equal to 20x. Next, let us have the standard form of the equation of the parabola with vertex hk. The standard form of the parabola with horizontal axis of symmetry, we have the square of y minus k is equal to 4p times x minus h. And for the parabola with vertical axis of symmetry, we have the square of x minus h is equal to 4p times y minus k. Let us have first the horizontal parabola. So the opening, if p is less than 0, the parabola opens to the left. If p is greater than 0, the parabola opens to the right. The equation of the latus rectum is x is equivalent to h plus p. Direction, we have vertical. The length of the latus rectum is 4p, or the absolute value of 4p. The endpoints of the latus rectum, we have h plus p as the x-coordinate, and to solve for the y-coordinate, we have k plus or minus 2p. For the axis of symmetry, the equation is y is equal to k, and the direction is horizontal. For the equation of the directrix, we have x is equal to h minus p. Direction, we have the vertical. And for the parabola with vertical axis or the vertical parabola, so we have focus, we have coordinates h and k plus p. If p is less than 0, it opens downward. If p is greater than 0, it opens upward. For the equation of the latus rectum, we have y is equal to k plus p. The direction of the latus rectum is horizontal. The length is 4p. The endpoints of the latus rectum, we have h plus or minus 2p, and for the y-coordinate, we have k plus p. The equation of the axis of symmetry is x equals h. The direction is vertical. The equation for the directrix, we have y is equal to k minus p. The direction is horizontal. Let us have illustrations for horizontal parabola with vertex hk. So for p is less than 0, the parabola opens to the left. This is the vertex, and this is where you are going to locate the focus. And this is the directrix. And these are the endpoints of the latus rectum. For p is greater than 0, the parabola opens to the right. This is the vertex, and this is the focus, and this is the directrix. For the vertical parabola with vertex hk, this is the illustration for the parabola opening upward, wherein you have the vertex located here. So this is the focus, 3 units up. So you count 3 units down and you draw the directrix. And since p is 3, so you count 6 units. This is the endpoint of the latus rectum. From the focus to here, that is 6, which is equivalent to 4p as the length of the latus rectum. And for the parabola opening downward, if this is the vertex, you count 3 units here if that's the value of your p. So this is the focus. From the vertex, you count 3 units and you draw your directrix. And from here to here, that's equivalent to 2p. From here to here, that's 2p. Or simply from one endpoint to the other endpoint, that's equivalent to 4p. Next. For example, determine the equation of the parabola in standard form that satisfies the given vertex is at coordinates -2, 3 and focus is at -4, 3. Draw the parabola, its focus, axis of symmetry, and directrix. For the solutions, the vertex here is with coordinates hk. So you have to identify first the values of h, which is -2, and k, +3. Solve for the value of p. So the coordinates of the focus is -4, 3. h plus p is simply equivalent to -4. And solving for p, this is equivalent to -4 minus h. You transpose h, then simplify. So -4 minus the value of h is -2. So p is equal to -2 plus 2, and p is equal to -2. So the value of p is -2. Use the equation of the parabola and substitute and then simplify. So k is 3, p is -2, and h is -2. So the square of y minus 3 is equal to 4 times -2 is -8. Simplify this part so you have x plus 2. So what we have is the square of y minus 3 is equal to -8 times the quantity x plus 2 as the equation of the parabola in standard form. And for the graph, the vertex, we have -2, 3. The focus is -4, 3. And the focus is always inside the parabola. Since p is less than 0, so the parabola opens to the left. And from here, that's equivalent to 2 units. From the vertex, you count 2 units and draw the directrix. The axis of symmetry is y is equal to 3 because the line passes through y is equal to 3. Take note, since the vertex and the focus are both on the axis of symmetry and that their y coordinates are the same, the axis of symmetry is line y is equal to 3. The focus is located to the left of the vertex, therefore, the parabola opens to the left. The equation of the parabola is of the form the square of y minus k is equal to 4p times the quantity x minus h, which is the equation of the horizontal parabola where p is less than 0. Next example. Determine the focus, the vertex, the length of the latus rectum, endpoints of the latus rectum, and the other parts and characteristics of the parabola. The square of x minus 3 equals -12 times the quantity y minus 2. And then you have to sketch the parabola. The given equation is the square of x minus 3 is equal to -12 times y minus 2. The focus is h, so the value of h is 3, and k is 2, So 2 plus p, which is negative 3, that is equivalent to negative 1. P is less than 0 because it's negative 3, so the parabola opens downward. The equation of the latus rectum is y is equal to negative 1. That is from k, which is 2 plus p negative 3. Direction is horizontal. The length of the latus rectum is 12 units or 4p. That's 4 times negative 3, and you take the absolute value, so it's positive 12. The endpoints, we have negative 3, negative 1, and 9, negative 1. You just simply substitute the values to this formula. And the equation of the axis of symmetry is x is equal to 3 because that is x equals h. Direction is vertical. The equation of the directrix is y is equal to 5 since it is coming from y is equal to k minus p. K is 2 minus negative 3, so that is equivalent to 5. And the direction is horizontal. So this is the graph. Vertex with coordinates 0, 3. The focus 3, negative 1. So it's 3 units down. You count 3 units and draw the directrix. And the equation of the directrix is y is equal to 5. This is the axis of symmetry equivalent to x equals 3. The endpoints, we have negative 3, 1, 9, negative 1. Next. Let us have the equations of the parabola in general form. If the vertex is 0, 0, the general form, we have x squared plus dx plus f is equal to 0. And y squared plus dy plus f is equal to 0. For the vertex hk, we have x squared plus dx plus ey plus f is equal to 0. And the other one is y squared plus dy plus ex plus f is equal to 0. For example, convert the standard equation of the parabola given x squared equals 12y into general form. So for the solutions, you copy the given and transpose 12y to the other side. So what we have is x squared minus 12y is equal to 0. So this is now the general form. Next, convert the equation of the parabola given the square of y minus 3 is equal to negative 8 times the quantity x plus 2 into general form. For the solutions, the square of y minus 3 equals negative 8 times x plus 2. This is the given equation. And you have to square the left side and apply distributive property to the right side. So square this. We have y squared minus 6y plus 9. Distribute negative 8x minus 16. Then simplify. Transpose negative 8x to the left side and negative 16. So what we have, y squared minus 6y plus 8x plus 9 plus 16. And combine 9 and 16, which is equivalent to 25. And this is now the general form. Next, for example 3, determine the standard equation of the parabola given y squared minus 12y minus 4x plus 28 equals 0. And identify the coordinates of the vertex, focus, and directrix. Sketch the parabola. For the solutions, the equation y squared minus 12y minus 4x plus 28 equals 0 is of the form y squared plus dx plus ey plus f is equal to 0. That's the general equation. So copying the given, all you have to do is to transpose negative 4x and positive 28. So what we have, y squared minus 12y is equal to positive 4x minus 28. Then you have to complete the square. Take the half of 12, that is 6. Square it, 36. And you also add 36 to the right side. And factor the trinomial, this trinomial. So what we have is y minus 6 times the binomial y minus 6. And combine negative 28 and 36. So what we have is 8. And simplify. This can be converted into the square of y minus 6 is equal to 4x plus 8. And we have now the standard form. This is the standard form wherein all you have to do is to factor out 4. So, taking out 4, 4x divided by 4 is x, 8 divided by 4 is 2. Now, since h is equal to negative 2 and k is equal to 6, thus, coordinates of the vertex, we have negative 2 and 6, coordinates of the focus, negative 1 and 6, and the directrix is x is equal to negative 3. And this is the graph. Vertex, negative 2, 6, focus, negative 1, 6. You need only to reflect the vertex, the focus, and the directrix. Next, let us have the applications of the parabola. For example, a satellite dish has a diameter of 4 feet. The depth of the dish is 1 foot at the center of the dish. Where can the receiver be placed? Let B the vertex be at 0, 0. And what are the coordinates of the point at the diameter of the dish? This is the figure. So this is the vertex, 0, 0. From here to here, that's 1 foot. And we are asked for the coordinates of the endpoints, and we need to find the focus. For the solutions, we have to find the value of P. Now, the standard equation of the parabola that we will use is x squared is equal to 4py because the vertex is at the origin and the parabola opens upward. From here to here, this will serve as the value of P. So, that is 1 foot. And since the value from here to here is 1 foot, so P is equivalent to 1 foot. So, for the focus, 0P, so that is 0, 1. And the endpoints, all you have to do is to substitute. So, negative 2 times 1, and then P for 1, and 2P, 2 times 1 and 1. So, what we have, the coordinates of the diameter, we have negative 2, 1, and 2, 1. So, the coordinates of the point at the diameter of the dish are negative 2, 1, and 2, 1. And the receiver can be placed at 0, 1. Example 2. The cables of a suspension bridge are in the shape of the parabola. The towers supporting the cable are 600 feet apart and 80 feet high. If the cable touch the road surface midway between towers, what is the height of the cable from the road at a point 150 feet from the center of the bridge? So this is the illustration. The height is 80 feet. The distance from here to here is 600. So half of this is 300. So from here to here is 150 feet. And we need to find the length of this portion. So for the solutions, find the value of P. So we have this equation, x squared is equal to 4py since the parabola opens upward. So let us substitute 300 to x. So the distance from here to here, that's 300. Then you square, equals 4p times 80. This is the length from here to here. And that is equivalent to 281.25. That's the value of P. Then we have to substitute the value of P to the equation x squared is equal to 4py. Using now 150. So 150 squared is equal to 4 times the value of P, 281.25 times y. And then the result of this is 22,500 is equal to 1,125y. Simplify, so y is equal to 20 feet. So the height of the cable is 20 feet. Do you have questions? If there is none, then see you next time. Bye!